This lab is all about connected and local IPv6 routes. As usual with these ad hoc labs, I'll tell you what to do first, then ask you to hit pause and do the lab, and I'll close with a demo of the lab. Let's jump in. So we're going to use this topology. Over on the right is router RC. It's like your core router, and we're mostly going to ignore it, other than to say that it has a WAN link connected to each of 3 branch office routers, and we're going to focus on those 3 branch office routers on the left. Each of those has a WAN link, as I mentioned, with an IPv6 address, and 2 LAN interfaces with IPv6 addresses on the top and bottom of each router, respectively. Now, part of your job is to interpret the IPv6 addresses. They all have this acronym GRP to begin. That's Global Routing Prefix. And in this case, that's the first 48 bits or 12 hex digits, and that's represented over here. So this diagram and documentation gives us a shorthand way to represent the IPv6 addresses used on those interfaces, so it gives you a chance to think about that. So what's your job for this lab? Well, from that drawing and that information there, predict all the connected routes on those 3 routers on the left. Likewise, predict all the local routes for all 3 of those, and then get into Packet Tracer and see if your predictions were correct. If you look in the description of this video, there's a link there to download a Packet Tracer file, open it up in Packet Tracer, and you can perform the lab. All right, it's time to hit pause and go make your predictions and then do the lab. So pause and do it. Here's 5 seconds before I move on with the lab. One more chance to hit pause before I show you the answers, counting down. All right, let's jump in and talk about it. The big deal is the connected routes. So let's talk about those. All the subnets will begin with this global routing prefix. So for this diagram, I've got the GRP acronym still at the beginning. But now I've got the prefixes listed instead of the interface addresses. And if you see here, we've got subnet 11, if you will, subnet 12, and subnet Baker 01 for the 3 subnets connected to router R1. And then if you look at router R2, subnets 13, 14, and Baker 02, and then subnets 15, 16, and Baker 03. So you can see there's a pattern there whenever someone planned this network. I planned it for lab, obviously, but you get the idea, right? Now, that's a very sparse diagram. So to give you a couple more perspectives, in this next diagram, it's the same information. I've just added the interface IDs. So if it's useful for you to come back to this timestamp and hit pause so you can both see the interface IDs and the subnets, feel free to do that. However, if you want to see the full prefix ID instead of this GRP acronym in the top, one more version of the same figure where I've taken the global routing prefix and just plugged the number in here. So 333 Fox 1234 11, 333 Fox 1234 12, and so on for all the subnets here. Those are the literal numbers that you should see in the connected routes in the lab when you jump in and do it. So here's the packet tracer file just after you should have opened it. And we see the routers R1, R2, and R3 on the left, and 2 LAN interfaces with the WAN interface connected over to router C on the left. So if you were to click and open up router R1 and use the CISCO password to get in, you'd get to the enable mode prompt after typing the enable command, and that's where I am to start here. Now I want to get an image of the lab up on the right as well, so give me a moment to arrange that. So now we have a reminder of what we were working from in the PowerPoint over on the right. Now I'm going to do a little typing here, and I'm going to show you some commands that don't work to start. These are the commands I would use on real gear because I think they work better in this case. For instance, show IPv6 route connected would show us only the connected routes, but Packet Tracer doesn't support it in version 8.2 that's available when I did this lab. And show IPv6 route local is also not supported. So those would be my preferred commands, but you can instead do show IPv6 route and just visually sort through the connected and local routes, and that's what we'll do here. So if we see here this first connected route, and I'm going to highlight some of the text, Notice the end of the highlight, it's gigabit Ethernet 00. So that's that top interface over there in the diagram. And it's got 3 Fox 1234. That's the global routing prefix. And then subnet 11 that we've got there. And then double colons, meaning zeros in the rest of the prefix all the way up to the end. And a prefix length of 64. And we'll see this pattern for all 3 of the connected routes. Here's the next one off gigabit 01. It's got the same global routing prefix. It's subnet 12. And then in this third one on the WAN link, it's off gigabit 020. It's got the same global routing prefix and subnet Baker 01 there. Then for the local routes that you see here, we see a local route for each of those 3 interfaces as well. Notice they all have prefix lengths of 128, and they have the complete IPv6 addresses of the interfaces, right? Not the prefix, but the complete addresses there, and here, and here. There's also a local route that's a placeholder for all well-known multicast addresses that you see down here. All right, so that's a bit about the connected routes and local routes on router R1. You can also use the show interface command, by the way. But I meant show IPv6 interface. And you can see things like this. The global unicast address on that interface, by the way, that's the upper interface in the diagram on router R1. It shows the address, which shows up in the local route, and the subnet that shows up in the connected route as well. So that's another command you can try. For this next part of the demo, I've already got router R2's console open on the left, and we've got the diagram on the right. So it's router R2 in the center from top to bottom that we're examining. So just doing an up arrow to retrieve a few commands. Let's look at the top interface on router R2 for a moment. We see the global unicast address, the full address, that should show up in a local route. And here's the prefix that the router calculated, which should show up in the connected route. In fact, let's go look and see if it does. So here off gig 00, we see the prefix that's got the 13 in the subnet part, the same global routing prefix of 3 Fox 1234. And we see a local route off that same interface, gig 00, and it looks almost identical except it has a non-zero value there at the end in the interface ID. So other connected routes, just to wrap things up there, is you've got this connected route off the bottom LAN interface, gig 01, subnet 14, if you will. And then on the WAN link off gig 020, we've got subnet Baker 02 connected over towards router C on the far right of the diagram. For this last case, we'll follow the same process. We're focused on router R3 from the diagram there. I've already got it open and in privilege mode, so what do we have here? Show IPv6 route. Did you predict the correct subnets? Well, let's take a look. We've got this top connected route off of gig 00. That's the top of the LAN interfaces. It's subnet 15. Then this connected route, it's on the bottom of the LAN interfaces, gig 01, subnet 16, if you will. And then the third of those was for the WAN link off of gig 020, subnet Baker 03. And that's it for the 3 connected routes. The 3 local routes look almost identical, except there's a non-zero interface ID value, all of them : 3 in this case. And all of those have a 128 prefix length, as is the convention with a local route. Hope you enjoyed this ad hoc lab and got into Packet Tracer a little bit. Subscribe and click the bell if you haven't already. I've got lots more lab videos and tons more labs than that on my blog site, so jump in there and check those out as well. Thanks for hanging out. I'll talk to you soon.